Welcome. Today, we're diving into a topic that often confuses even tech enthusiasts: the difference between artificial intelligence, machine learning, and deep learning. These terms are frequently used interchangeably, but they actually refer to distinct concepts within the world of technology. By the end of this video, you'll have a clear understanding of what sets each apart, how they relate, and why it matters. Let's start by setting the stage with a quick overview before we break down each term in detail. Artificial intelligence, or AI, is a broad field in computer science focused on creating systems that can perform tasks typically requiring human intelligence. These tasks include reasoning, learning, problem-solving, perception, and even understanding language. AI is the overarching concept that encompasses both machine learning and deep learning. Think of AI as the science of making machines smart, whether it's through simple rule-based systems or more complex learning algorithms. Next, let's see how machine learning fits into this picture. AI is already part of our daily lives, often in ways we don't even notice. From voice assistants like Siri and Alexa to recommendation systems on Netflix and Amazon, AI powers many of the tools and services we use. It's also behind technologies like facial recognition, smart home devices, and even spam filters in your email. These examples show how AI can be both visible and invisible, working behind the scenes to make our lives easier and more efficient. Machine learning, or ML, is a subset of AI. It refers to systems that can learn from data and improve over time without being explicitly programmed for every task. Instead of following fixed rules, ML algorithms identify patterns in data and use these patterns to make predictions or decisions. For example, an email spam filter learns to recognize spam by analyzing thousands of emails and identifying common features of unwanted messages. Let's explore how ML works in more detail. Machine learning relies on large amounts of data to train models. These models are mathematical representations that can make predictions or decisions based on new data. The process typically involves feeding data into an algorithm, which then adjusts its internal parameters to minimize errors. Over time, the model becomes better at its task. For instance, a recommendation system learns your preferences by analyzing your past behavior and suggesting new content you might like. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning uses labeled data to teach the model. Unsupervised learning finds patterns in unlabeled data, and reinforcement learning learns by trial and error, receiving feedback from its actions. Each type is suited for different kinds of problems, from image classification to game playing. Understanding these types helps clarify the range of tasks ML can tackle. Machine learning is everywhere. It powers spam filters, fraud detection systems, personalized recommendations, and even self-driving cars. For example, banks use ML to detect unusual transactions that might indicate fraud, while streaming services use it to suggest movies and shows tailored to your tastes. These real-world applications demonstrate how ML adapts and improves with more data, making technology smarter and more responsive. Deep learning, or DL, is a specialized subset of machine learning. It uses artificial neural networks inspired by the human brain to process data in complex ways. Deep learning excels at tasks like image and speech recognition, natural language processing, and even playing complex games. The key difference is that DL models can automatically extract features from raw data, reducing the need for manual intervention. Let's see how deep learning works under the hood. At the heart of deep learning are neural networks, which are made up of layers of interconnected nodes, or neurons. Each layer processes information and passes it to the next, allowing the network to learn increasingly abstract features. For example, in image recognition, early layers might detect edges, while deeper layers recognize shapes and objects. This layered approach enables deep learning models to handle very complex data and tasks. Deep learning has revolutionized fields like computer vision, speech recognition, and language translation. It's the technology behind self-driving cars, facial recognition systems, and voice assistants that understand natural language. For instance, DL enables your phone to unlock with your face or transcribe your speech into text. These breakthroughs are possible because deep learning models can process vast amounts of data and learn intricate patterns. To summarize the relationship, artificial intelligence is the broadest concept, encompassing any technique that enables computers to mimic human intelligence. Within AI, machine learning is a subset focused on learning from data. Deep learning is a further subset of ML, using neural networks to tackle especially complex problems. Think of it as a set of Russian dolls, with AI as the largest, ML inside it, and DL at the core. Let's quickly recap the main differences. AI is the umbrella term for machines that can perform intelligent tasks. Machine learning is a way for computers to learn from data, and deep learning is a specific technique within ML that uses neural networks. Each level adds more complexity and capability, but also requires more data and computational power. Understanding these differences helps you better grasp the technology shaping our world. It's important to note that not all AI uses learning. Some AI systems are rule-based, following predefined instructions to make decisions. Others, like those using machine learning, adapt and improve over time. Rule-based AI is great for predictable tasks, while learning-based AI excels in dynamic, data-rich environments. This distinction highlights the evolution from simple automation to more adaptive, intelligent systems. Traditional machine learning often requires feature engineering, where experts manually select and design the input variables that help the model learn. For example, in predicting house prices, features might include location, size, and number of bedrooms. This process can be time-consuming and requires domain knowledge. Deep learning, on the other hand, can automatically extract features from raw data, which is a major advantage in complex tasks. Deep learning models are powerful, but they come with a cost. They require massive amounts of data and significant computational resources to train effectively. Training a deep neural network can take hours or even days on specialized hardware. This is why deep learning has become more practical only in recent years, as data availability and computing power have increased dramatically. AI can be divided into symbolic and connectionist approaches. Symbolic AI uses logic and rules to represent knowledge, while connectionist AI, like neural networks, learns from data. Symbolic AI is good for tasks that require explicit reasoning, such as playing chess. Connectionist AI excels at pattern recognition, like identifying faces in photos. Both approaches have their strengths and are sometimes combined for more robust systems. Artificial intelligence is the science and engineering of creating machines that can perform tasks requiring human-like intelligence. It covers a wide range of techniques, from simple rule-based systems to advanced learning algorithms. AI aims to replicate or simulate human cognitive functions such as reasoning, learning, perception, and decision-making. Machine learning is a subset of AI focused on developing algorithms that allow computers to learn from data. Instead of being explicitly programmed for every task, ML systems identify patterns and make predictions or decisions based on data. ML is widely used in applications like recommendation systems, fraud detection, and image recognition. Deep learning is a specialized area within machine learning that uses artificial neural networks with many layers. These networks can automatically extract features from raw data, making them especially powerful for tasks like image and speech recognition. Deep learning has enabled major breakthroughs in AI, particularly in areas requiring complex pattern recognition. The concept of artificial intelligence dates back to the 1950s, when researchers began exploring ways to make machines think like humans. Early AI focused on symbolic reasoning and rule-based systems. Over time, advances in computing power and data availability led to the rise of machine learning and, eventually, deep learning. Today, AI is a rapidly evolving field with applications across industries. Machine learning became practical as the amount of digital data exploded and computers became more powerful. The ability to process large datasets enabled ML algorithms to learn more effectively, leading to breakthroughs in fields like finance, healthcare, and marketing. The data revolution continues to drive advances in ML, making it a cornerstone of modern AI. Deep learning's rise is closely tied to advances in graphics processing units, GPUs, and the availability of massive datasets. These factors made it possible to train deep neural networks efficiently. As a result, DL has achieved human-level performance in tasks like image classification and language translation, sparking a boom in AI research and applications. AI's applications are incredibly broad, ranging from healthcare and finance to entertainment and transportation. In healthcare, AI assists with diagnosis and personalized treatment. In finance, it helps detect fraud and manage investments. In entertainment, AI powers recommendation engines and content creation. The versatility of AI makes it a transformative force across sectors. You encounter machine learning every day, often without realizing it. When you use a search engine, receive product recommendations, or see personalized ads, ML is working behind the scenes. Even your smartphone's autocorrect and voice recognition features rely on ML algorithms. These examples show how ML has become an integral part of modern technology. Deep learning has made significant breakthroughs in computer vision, enabling machines to recognize objects, faces, and scenes with remarkable accuracy. This technology powers applications like autonomous vehicles, medical image analysis, and security systems. The ability to process visual data at scale is one of DL's most impressive achievements. Natural language processing, NLP, is a branch of AI that enables machines to understand and generate human language. NLP powers chatbots, language translation, and sentiment analysis. Recent advances in deep learning have dramatically improved NLP, making it possible for AI to understand context, nuance, and even humor in text. Predictive analytics is a major application of machine learning. By analyzing historical data, ML models can forecast trends, customer behavior, and even equipment failures. Businesses use predictive analytics to optimize marketing, manage inventory, and improve customer service. The ability to anticipate future events gives organizations a competitive edge. Deep learning has transformed speech recognition, enabling virtual assistants to understand spoken commands with high accuracy. DL models can transcribe speech to text, recognize different accents, and even detect emotions in voice. This technology is used in smartphones, customer service bots, and accessibility tools for people with disabilities. AI systems are increasingly used to support decision-making in complex environments. For example, AI can help doctors choose the best treatment plan, assist pilots in navigation, or guide financial analysts in investment decisions. By processing vast amounts of data and identifying patterns, AI provides valuable insights that enhance human judgment. Personalization is a key strength of machine learning. By analyzing user data, ML algorithms can tailor recommendations, content, and experiences to individual preferences. This is why your social media feed, online shopping suggestions, and music playlists feel uniquely suited to you. Personalization enhances user satisfaction and engagement. Deep learning is at the core of autonomous vehicle technology. Self-driving cars use DL models to interpret sensor data, recognize objects, and make real-time driving decisions. These systems must process vast amounts of information quickly and accurately to ensure safety and reliability on the road. Despite its power, AI has limitations. It can struggle with tasks that require common sense, creativity, or emotional intelligence. AI systems are only as good as the data and algorithms they're built on, and they can sometimes make mistakes or exhibit bias. Understanding these limitations is crucial for responsible AI development and use. Machine learning faces challenges such as data quality, overfitting, and interpretability. Poor quality data can lead to inaccurate models, while overfitting occurs when a model learns noise instead of useful patterns. Additionally, some ML models are difficult to interpret, making it hard to understand how decisions are made. Addressing these challenges is an active area of research. Deep learning models are often described as black boxes because it's difficult to understand how they arrive at their decisions. This lack of transparency can be problematic in critical applications like healthcare or finance, where explainability is essential. Researchers are working on techniques to make DL models more interpretable and trustworthy. As AI becomes more powerful, ethical considerations become increasingly important. Issues like privacy, bias, and accountability must be addressed to ensure AI is used responsibly. Developers and organizations need to consider the impact of AI on society and strive to create systems that are fair, transparent, and beneficial for all. The future of machine learning includes advances in automated machine learning, AutoML, improved interpretability, and the integration of ML with other technologies like edge computing and the Internet of Things, IoT. These trends will make ML more accessible, efficient, and impactful across a wider range of applications. Deep learning continues to push the boundaries of what's possible in AI. Researchers are exploring new architectures, such as transformers and generative models, that can create realistic images, write coherent text, and even compose music. These advances promise to unlock even more powerful and creative AI applications in the future. AI is most effective when it collaborates with humans, augmenting our abilities rather than replacing us. In medicine, AI assists doctors in diagnosing diseases. In business, it helps analyze data and optimize operations. The future of AI lies in human-AI collaboration, where each complements the other's strengths. Machine learning is becoming more accessible thanks to open-source tools, cloud platforms, and educational resources. This democratization allows more people and organizations to leverage ML, driving innovation and expanding its impact. As barriers to entry fall, expect to see ML used in even more creative and diverse ways. Deep learning is already making a real-world impact, from improving medical diagnoses to enabling new forms of art and entertainment. Its ability to process complex data and learn intricate patterns is transforming industries and opening up new possibilities. As DL continues to evolve, its influence will only grow. The future of artificial intelligence is both exciting and uncertain. As AI systems become more capable, questions about ethics, safety, and societal impact will become even more important. Ongoing research, thoughtful regulation, and public engagement will shape how AI develops and how it benefits humanity. A promising direction in machine learning is lifelong learning, where systems continuously learn and adapt to new data and environments. This approach aims to make ML models more flexible and robust, capable of handling changing conditions and new challenges over time. Some researchers believe deep learning could be a stepping stone toward artificial general intelligence, AGI, machines that can understand and learn any intellectual task a human can. While AGI remains a distant goal, advances in DL are bringing us closer by enabling machines to learn more flexibly and autonomously. To wrap up, artificial intelligence is the broad science of making machines intelligent. Machine learning is a subset that enables computers to learn from data, and deep learning is a further subset that uses neural networks for complex tasks. Each plays a unique role in the evolution of smart technology. Understanding their differences helps us appreciate the power and potential of modern AI. Thank you for joining us on this journey through artificial intelligence, machine learning, and deep learning. We hope you now have a clearer understanding of how these concepts differ and how they work together to drive innovation. As technology continues to advance, staying informed about these key ideas will help you navigate and make the most of our increasingly intelligent world.